So we're going to start on section 6.3, Hess's law. It's really hard to explain this in a way that makes sense, but it's easier to show you a problem and go from there. So we're going to switch to the back of your book. We're going to go over problem 63. At the very bottom, it gives you the formula that we're trying to figure out. It is calcium carbide plus 2 waters in liquid form going to calcium hydroxide plus ethylene gas. Okay, and then they give us 5 different reactions that if we add up all of those reactions, we need to make this reaction. And by Hess's law, if you can put other reactions together, then you get the same energy. It's a state function. It doesn't matter the path you take to get there as long as you get there. So the first one that we're going to write down is going to be the first formula they give us, the calcium solid plus 2 graphites goes to calcium carbide, but we have to flip that. So it's going to be CaC2 solid going to 2 carbon graphite plus calcium, which is acceptable, but if you flip it, you have to flip the sign on the energy. So instead of negative 62.8 kilojoules, this is going to be 62.8 kilojoules. Next, we're going to go down to the third one they give us, the calcium oxide plus water going to calcium hydroxide. That one is already set up the way that we need it to be because the hydroxide is on the right side. So we're just going to write that one down. What I mean by the right side, let me quickly show you here is calcium carbide, and this had calcium carbide, and they're both on the left side here. So that works out. So in the next one, we're going to do the calcium hydroxide, and we need it to be on the right side, and it already is, so we're just going to write that one down. Okay, and since it's written the same way, we keep the same sign, and so it's negative 653.1 kilojoules. Alright, so that one has our calcium hydroxide and our calcium hydroxide. It also has one of our water, so I won't box it all the way because we're not done yet, but that one also plays into it. Now we have this calcium oxide here that we need to get rid of, because anything that's extra we have to get rid of. So we go up to the second formula they give us, and now we want them on opposite sides because we're trying to get rid of them, not keep them. That one is already on the opposite side, so we can write that out. Calcium solid plus 1/2 oxygen, and normally you can't do half of an oxygen, but when you are doing state function things, it's okay because it's not that you actually have a half of an oxygen, you're just calculating with that, so it works out. We don't have to flip the sign because it is the same way. So 635.5 kilojoules, and now we can say that my calcium is gone. Let's do it in red so it's a little bit easier to distinguish. And my calcium oxide is gone. Okay, that leaves me with this carbon and this oxygen that I've got to work with. So we're going to go to the fourth one that they gave us. The ethylene plus 5/2 oxygen goes to 2 carbon dioxides and water. We want ethylene on this side, so we have to flip that one. So we'll flip that around and we'll go water plus 2 carbon dioxides goes to 5/2 oxygen and ethylene. Alright, and now we can say I have my ethylene here that I need, I have my ethylene here, I also have my second water that I need, so I can go ahead and box my waters up. Alright, that means that I have everything up here that I need, so I just need to make sure that everything cancels out now. I have nothing right now that's going to cancel, so I've got to put this last one in and hope that it cancels everything out for me. Let's write it down and see what we got. C graphite plus O2 gas goes to carbon dioxide. Well, I need 2 carbon dioxides, I need 2 graphites, and I need more oxygen. So the other rule that you can do is you can times this by any number, and all you have to do is times the result by any number. So this is 393.5 kilojoules. If you times that by 2, since we want to double that, we're going to get negative 787.0 kilojoules. And I've got to write this other one in here. This one we flipped, this one right here we flipped, so it's going to be 1300 kilojoules instead of negative 1300 kilojoules. Now let's make sure that everything cancels out. I have 2 graphites. I have 2 graphites up there. I have 2 oxygens and then another half, so that's 5 half oxygens right there, and 2 CO2s, 2 CO2s. So everything canceled out except for the things I needed to stay. So this by state function, if I add all of these things together, will give me the energy that my original formula needed. I add all of that together and I get negative 714 kilojoules, and that would be my answer.